this video, we are going to be using this question to explain the concept of curvilinear motion. The question says, a car traveling on a curved section of highway at a velocity of 105 meters per second as shown in figure 6. A constant deceleration rate occurred when the driver of the car applied brakes. Assuming that the speed of the car reduces to 74 meters per second after 10 seconds, determine the acceleration of the car immediately after the brakes are applied. Okay, so this is the diagram which shows the motion of a car on a curved path. So this is actually a question to help us understand curvilinear motion. Whenever an object moves around a cycle, there are two types of acceleration that occurs. The first acceleration is called the tangential acceleration, and the second acceleration is called the normal acceleration. So let's look at our parameters. In the question, you are given that a car is traveling with a velocity. So initial velocity was given. Initial velocity called that u was given as 105 meters per second. Okay, around a curved path. Now, the question says that when the brakes was applied, the speed of the car reduces to 74 meters per second. So the final speed or final velocity, which is v, is given as 74 meters per second. You're asked to find the acceleration in 10 seconds, and time t was given as 10 seconds. But let's go through this curved path and see. Now, observing the diagram, notice that from this point to the center of the cycle, this is now a cycle. Just imagine having this to be a cycle because we're talking about curvilinear motion. Now, from any point or from the center of the cycle to any point on the cycle is called radius. So, which means this arm is a radius arm, simply called the radius of curvature. Whenever an object is undergoing a circular motion, the radius arm is called the radius of curvature. And the radius of curvature was given to us there as 270,000 centimeters. So therefore, we were given radius of curvature. So the radius of curvature R was given as 270,000 centimeter. Of course, we convert this to meters simply dividing 270,000 by 100. So this implies that our radius of curvature becomes 270,000 divided 100 gives us 2,700 in meters. So this is our parameter. So I said whenever motion is made on a curved path, we have two types of acceleration. We have the tangential acceleration and then we have the normal acceleration. So if you have a cycle, okay, now the tangential acceleration is the acceleration tangent to the cycle, something like this. This is called at, whereas the normal acceleration is at 90 degrees to the tangential acceleration. So this is called an. Now the tangential acceleration is as a result of the motion of the particle. Okay, so tangential acceleration is given at as simply the change in velocity with respect to change in time. So the tangential acceleration is as a result of motion. Now, what is change in velocity? Final speed v minus initial speed u all over what? Time. Okay, so therefore our tangential acceleration at is equal to the final speed was given as 74 meters per second minus the initial speed was given as 105 divided by the time was given as 10 seconds. So this is equal to 74 minus 105. This gives us negative 31 divided by 10. Therefore, this implies that the tangential acceleration is equal to minus 3.1 meters per second squared. So this is our tangential acceleration. Next, we need to find the what? Normal component of the acceleration. Now, the normal acceleration the normal acceleration an is given as v squared all over radius of curvature. This is how you find your normal acceleration, where v is the motion of the car round the cycle. Okay, so the car is moving at 105 meters per second. So our normal acceleration is simply 105 to the power of 2 divides radius of curvature, which is 2700. So this implies by that the normal acceleration is equal to, so let's obtain 105 squared. That gives us 11025. 11025 divides 2700. So this simply implies that the normal acceleration is equal to, we have this to be 4.08 meters per second square. So this is our normal acceleration. Therefore, the magnitude of the acceleration of that car is now given simply as the square root of the tangential acceleration squared plus the normal acceleration squared. So this is equal to the square root of the tangential acceleration give us minus 3.1 squared plus normal acceleration give us 4.08 squared. 4.08 squared. So let's punch everything together. Alright, so punching everything together gives us, and taking square root, we have acceleration to be 5.12 meters per second squared. So this is the acceleration of that vehicle moving around the curved path. Alright guys, so that's it on curvilinear motion. I will see you in the next video with more questions on curvilinear motion. Thanks and cheers.